The topic is 2D transformation. Transformation are of four types: rotation, translation, scaling, and shearing. First, rotation, meaning rotate an object uh, in counterclockwise direction or towards origin. So here the point x1, y1, it is a point of an object. Object contain many coordinates. We are rotating or we are applying transformation on only one coordinate. The same method will be applied to remaining coordinates. So x1 y1 is shifting to x2 y2 here. First object's point or object's coordinate was at x1 y1 position. It was here, and it was here meaning it was at angle A. It is rotation, so we are rotating it with angle B. The x1 y1 coordinate is rotating with angle B. Similar remaining coordinates of object will be rotated. This is the matrix of rotation, how it is derived, that we will see in further slides. It is translation. Translation meaning both coordinate x and y. We are adding some value in x coordinate and y coordinate. For example, if there is a coordinate of this hut x1 y1, and we are adding value tx in x1 and ty in y1, and there will be some related coordinate to x1 y1. Similar remaining coordinate of the object contain many coordinates, so the same method will be applied to remaining coordinate. This is the translation matrix. Here tx is the value by which uh, what we will add in x direction, and ty is the value what we will add in y direction. Translation means shifting an object from one place to another. Scaling means changing the size of an object. It may be increase in size or it may be decrease in size. So this default matrix is for increase in size. Here sx and sy, the scaling coordinate in x direction and y direction. If the size of object is decreasing, not increasing, then we will use term 1 upon del x and 1 upon del y instead of del x and del y. If object size is increasing thrice, then del x will be 3. If it is increase in only x direction, if it is increasing both direction, then del y will be also changed to 3. So this is the matrix of scaling. This is scaling matrix, del x and del y, whatever size is given in the question. Shearing. Shearing usually apply to the object, to square or rectangle. In scaling, there are two types of scaling: x shear and y shear. In scaling, one edge one edge is constant, while like here this edge and here this edge is constant, while other lift or drag in x direction or in y direction. In y shear, the one edge is tilted, this edge is tilted to some shearing factor. So it is y shearing factor is zero point 0.5, here it is tilted or it is lifted up with zero point 0.5 factor, while x coordinate remains same. Here is x is 4, here is x4, and it is remains same in y shearing. While in x shearing, one edge will be constant, so this edge is constant here, and because it is at x shearing, so y factor will remain same. It is 3 in original, so it is 3 here. And x vector, we are dragged it, we drag the edge, so it is dragged with zero point 0.5 value. It is point 2.5 from 2 and 4.5 from 4. Then now we calculate matrix to solve numericals of these transformation. First is the rotation matrix. To rotate a line or polygon, we must rotate each of its vertex. Yes, to rotate any object, we need to rotate, or to transform any object, we need to transform its coordinate one by one. So we will apply these transformation, this type of transformation to only one coordinate, and the similar method will be applied for another coordinates. Here, to rotate point x1 y1 to point x2 y2, we can see that we need to calculate rotation matrix. How we will calculate rotation matrix? Um, we will do it through this diagram. And this is the angle A, point x1 y1 at angle A, and you can see through the diagram the value y1 meaning this value is y1, and x1 meaning this value is x1. Then sine A will be, sine is height upon hypotenuse, so sine A equal to y1 upon r, the hypotenuse value is r. And cos A is base upon hypotenuse, so cos A will be x1 upon same r. uh, when the coordinate is shifted with angle beta, or with angle B, the coordinate here x1 y1, it is at angle A, it is now rotated with angle B, and reached point x2 y2. Here angle A plus B, for angle A plus B, for angle A plus B, the height is y2 and base is x2. So is sine A plus B, here sine A plus B equal to, because for we are checking for angle A plus B is equal to this height is y2. When hypotenuse is same, this value r will be here also, so it is y2 upon r. And cos A plus B equal to base upon hypotenuse, so base of this x2 y2, base is x2, so x2 upon r. So these are the values we have calculated through the diagram. Sin A plus B, cos A plus B, sin A and cos A. Now we will explore or expand sin A plus B formula. We know already cos A plus B formula, we know already. Then after expand the formula, we will put sin A's value and cos A's value in this formula. Sin B and cos B term will remain extant, or will remain same. Uh, these values sin B and cos B will be given in the numerical, and according to the numericals given value, we will put these value into question. So sin A plus B equal to sin A cos B and cos A sin B, and cos A plus B, here we will put the value of sin A cos A, here also cos A and sin A. Cos B and sin B value we don't have yet, so it will remain same. Sin A and cos A value is given, it is here sin A and cos A, that we will put in this equation. So after submitting value, the equation will be y2 upon r equal to this. So r will be cancel out, then the equation will be like this. Similar, we will write the equation or calculate the equation for x2. So after getting these two equations, we can write this matrix. These equation, we can write this matrix, and by this matrix we can calculate this matrix. How this matrix is is driven from this matrix? When we multiply this one into x1 y1 coordinates, we will get these equations. You can check it, or you can, when we multiply this matrix into x1 y1, we will get equation what we have derived. So you can multiply and check it. Then translation. Translation meaning shifting x and y value, or just shifting object from one place to another, and another at another place there will be two different value of x coordinate and y coordinate. So what will be the difference of x, tx and ty will be used in translation matrix. For example, object is translate by tx in x direction and ty in y direction. This is the matrix we will use to solve numericals. If we will have value of tx 2 or ty in 3, then we will put accordingly in the matrix. Then scaling, we have already seen scaling matrix before. So the term, whatever scaling in x direction and y direction given in numerical, we will put here. If object is scaled in x direction only, not in y direction, then we will put del y value to 1. If it is scale in only y direction, not in x direction, then we will put del x value is 1, and remaining will be del y and del x according to numerical. These are the matrix we have seen in previous slide. Third, it is 3 cross 3 matrix. While we have drive only these values, so it is constant value always. It will be like that only. The third row we set to 0 0 and 1. Third column and third row also it will remain same in all transformation. It is 0 0 1 and is constant here also. And in translation, last row is 1, because in translation matrix last column is not set to 0. It is dx and dy, and because to convert it into 3 cross 3, last row is set to 0 0 1. So these are all matrix. So there is a numerical of scaling. The question is given, if we scale a line between 0 1 and 2 1, this is the question. This is the line 0 1, and at 2 1 we need to scale it twice to its length. And this is also given the left hand end point does not move. So this point, left hand point, will be at its original position before scaling, and after scaling it does not move. So we need to calculate point after scaling. So one point will remain same, we need to calculate another point, meaning what will be the value of second point. So as we have already seen scaling matrix. Scaling, because it is a line, so length will be changed only, width will remain same, meaning y, del y value will remain same. That is why it is 1. Or x length is will be twice, so del x is 2. So del x value is 2 here, del y value is 1 here for both coordinate. For this is we apply for applying for first coordinate, this is we applying for second coordinate. First coordinate is 0 1, so we are putting value 0 1 here. 1 will remain constant always in this multiplication of transformation. Here also the second point is 2 1, so we have written 2 1 here, and 1 is remain constant. When we multiply these matrix, meaning this, let's see, so when we multiplying this matrix to this, we are getting this matrix. Similar, we are multiplying this into this, we are getting this matrix. What is the meaning of these matrix? uh, the resultant coordinates are 0 1. The 1 will remain constant always, and the second endpoint will be 4 1. So this will be the resultant, or after solution we have got these coordinate 0 1 and 4 1, 0 1 and 4 1. This is another fixed point scaling. Fixed point meaning a point is given. In the last question we did scaling with origin, and here we we don't uh, have to scale it with origin. While the one fixed point is given, the point is 2 1, scale by 2 with 6.21. So line starting point is 2 1, and ending point in question is 4 1. It is 2 1, it is 4 1 before scaling. This is the resultant line. We will calculate it. So what we need to, we have to do with the fixed point scaling. Whenever we do such transformation, either scaling or rotation or translation, uh, when point is not at origin, what we need to do, we need to shift point to origin. Then we apply any transformation, either it is scaling or rotation or transformation, then shift the object back to its original position. So here also, first what we have to do, we have to shift it to origin, scale it from here, then shift it back to its original position. So there are three operation, you can see that. First operation, translation. Translation, we are translating it to origin. Default translation matrix is for towards origin. So what matrix we have seen before in slide, it was for uh, shifting towards origin. Default rotation matrix is also for towards origin, meaning anti-clockwise direction. So first operation is we need to translate it towards origin. This is operation 1. Then we will scale it, so it will be operation 2. We need to multiply it. Third, we need to inverse translate it to its original position. So there will be three operation we need to multiply. So you can see here in matrix there are three matrix. First is for translation because it was towards origin, and default translation matrix is for towards origin. So here it is default translation matrix, where tx value meaning x shift, we need to x shift is 2 and y shift is 1. 1 is constant always. So it is translation, first translation matrix. Then we need to scale it. Here scaling value, x scaling, because it is line, so it will scale in x direction only, because length will be changed, width will remain same. So scaling factor meaning sx will be 2 and sy will be 1, and this one is constant. Then we need to inverse translate it. So inverse translation meaning -2 in x direction, -1 is y direction, because lines coordinates are, initial points are 2 1. So x value is 2 and y value is 1. It is given in the question. So 2 1 we need to shift first towards origin, then reverse, a revert direction. So when we multiply mm, these three matrix, we will get this resultant matrix. Now what we have to do, we have to multiply coordinate with resultant matrix. This is the resultant matrix. Our first coordinate was 2 1. So 2 1 will be multiplied with it, and we will get this 2 1 1 point, meaning coordinate is 2 1. Then we will multiply resultant matrix with last point. Last point is 4 1. So we write it as 4 1 1, and after multiplication we get 6 1 1, meaning resultant coordinate is 6 1. So this will be the resultant line will be in between 2 1 and 6 1. So it is 2 1 and it is 6 1. This will be resultant line. Then with rotation it is also same. If we want to rotate with a fixed point, because we can see that this object is not at origin, so what we need to do, we need to shift it at origin, then it will be rotate, then it shifted to its original position, meaning in this rotation there will be three operation: translation, rotation, then inverse translation. So it is here, first we are translating, need to translate it towards origin, then rotation matrix, or at origin we will rotate this cube, a square, then we need to inverse translate its to its original position. So when we multiply all these three matrix, we will get this resultant matrix, and we need to multiply this resultant matrix with coordinate, or whatever coordinate given with the question. So that we will see in with numerical. Shearing we have discussed, and this is the shear value, x shear and y shear. If it is y shear, then a shearing coordinate and matrix will be like this, and b is y. If it is the y shearing value is a and x shear value is b. So if it is shearing, for example, we have seen in slide it was shearing with zero point 0.5 value, then a will be zero point 0.5, and if x shear value is, if it is tilting or dragging in x direction with zero point 0.5 factor, then b's value will be zero point 0.5 in matrix, and then we multiply this matrix with all four coordinates to get the resultant object. Then reflection, object's reflection, there are some metrics, these are fixed metrics. If it is asked in exam that object is reflected by y direction, y axis, you need to multiply this matrix with all coordinate of object, whatever coordinate x1 y1 and given for this one is fixed. And if it is with x direction, then this matrix is fixed, the value, middle value is -1. So you need to multiply this matrix with object coordinates. There are more possibility of reflection is object is reflecting by both x and y direction. So it is like that. It is reflecting from here to here, then matrix will be this one. If it is reflecting by the line y equal to x, meaning this type of line, it is line at 45-degree angle. So if object is, this is the object, this is the line, if this is the object, it will be after reflection, and this matrix is fixed. You need to multiply coordinate with this matrix. So this is all about this lecture. We will see more numerical in next videos. Thank you.